Okay, so hi everybody. So today we're going to do 5-Minute Math episode 3, and this is going to be over arithmetic and geometric sequences and series. I found it hard to kind of take one or two questions and really grab the essence of everything that falls into there. So I guess I'm going to do a couple of classic types of problems with sequences and series. So let's just jump into it. Okay, so Alice and Bob are playing a game. Alice starts first. On Alice's turn, she flips a coin. If she gets ahead, she wins. If not, it becomes Bob's turn. On Bob's turn, he flips a coin. If he gets tails, he wins. If not, it becomes Alice's turn. What is the probability that Alice wins the game? This is like the classic arithmetic geometric sequence series question that there is out there. It's like I see this one pop up all the time. Okay. So I guess we should ask ourselves, okay, well, how exactly does this game work? So they basically take turns flipping a coin, and whoever flips, so if Alice gets ahead, she wins. If Bob gets a tails, he wins. It doesn't really matter because it's 50-50 chance anyway, but that's basically how it works. So how does she win? Well, how she'd win is, and we're trying to find the probability, right? So the way that she'd win is, well, how could she win? She could win on the first try. So she gets a heads right away. Or she could win on her second flip, or she could win on her third flip, and she continues along, or she could win on the nth flip, or whatever. Like, just keep going, right? This game could literally last forever. So how do we find this? Okay, well, let's find out the probability that she wins. So the probability that she wins is the fact that she gets ahead on the first try. Well, that is just 1/2. That's it. Now, if she's going to win on the second trip, that means she has to lose, Bob has to lose, and then she has to win. So lose, and then lose. Okay, now I'm going to rewrite this in a second. Okay, now the probability that it's 3 then, well, how would that happen? She loses the first time, Bob loses, she loses, Bob loses, he loses. And then the pattern continues. Okay, so if you take a look, this is 1/2 to the first power plus 1/2 to the third power plus 1/2 to the fifth power, and then so on. So what type of a series is this? And hopefully you said that this is a geometric. So now you have to figure out, okay, well, what is the common ratio going from this to this to this to this and so on? What do you multiply by each time? Okay, now if you forget how to do this, the common ratio, you take any term in that sequence and you divide it by the prior one. So I'm going to take 1/2 to the power of 5 divided by 1/2 to the power of 3. Well, that's equal to 1/2 squared. And if you don't see that, just you can do out the math there. Okay, so that is what the common ratio is. This is a geometric series. Well, how do you find the sum of a geometric series, an infinite geometric series? The formula is given by S is equal to A of 1 all over 1 minus R. Well, A of 1 is the first term in that series, so that's just 1/2. All over 1 minus the common ratio. The common ratio is 1/4 because it's being squared. So this is 1/2 divided by 3/4, which is equal to 4 over 2 times 3. So that's equal to 2/3. Okay, so the answer is 2/3. Okay, like I said, very classic problem. This is a really good problem because it brings in combinatorics, it brings in probability, it brings in infinite geometric series, brings on a lot of different things. Okay, number 2, and this one's kind of hard to understand. So in the game of Frood, whatever that is, dropping n Froods gives a score of the sum of the first n positive integers. Dropping n Froods gives a score of the sum of the first positive integers. We'll deal with that in a second. Well, let's see what's right now. For example, dropping 5 fruits scores 1 plus 2 plus 3 plus 4 plus 5, which is 15. Okay? Now, eating n fruits, so we have 2 different events here. We have dropping and we have eating. So eating n fruits earns 10 n points. For example, eating 5 fruits earns 10 times 5, 50 points. Okay, so what is the least number of fruits for which dropping them will earn more points than eating them? So what's the least number of fruits for which dropping them, right here, will earn more points than eating them? For example, if I dropped 1 and ate 1, then dropping 1 would earn me 1 point, but eating 1 would earn me 10 times 1, which gives me 10. So obviously 10 is bigger than 1. Okay, if I did 2, so for dropping, it'd be 1 plus 2, which is equal to 3. And for eating, it'd be 10 times 2, which gives me 20. Obviously 20 is more than 3. So I have to figure out when this amount is going to be more than 10n right there. Well, the key to doing this is understanding what's the equation for the sum. What's the equation for the sum of the first n positive integers? So hopefully you know this. S is equal to n times n plus 1 all over 2. That's the sum of the first positive n integers. And what I want to know is when is this going to be greater than 10n? Now, how I do this is I actually don't deal with inequality. I set them equal to each other because I know this starts off smaller than this one. And what I want to do is I want to keep building it until it gets to that point. So I'm going to say n times n plus 1 all over 2. When is that going to be equal to 10n? Well, multiply both sides by 2. So that gives me n times n plus 1 is equal to 20n. Okay, which gives me then n squared plus n minus 20n is equal to 0. Okay, so keep solving. So I have n squared, n minus 20n is minus 19n is equal to 0. So factoring out an n, I have n minus 19. So I have n is equal to 0 and n is equal to 19. So obviously, if we didn't do any of them, they'd be equal to each other. And they also be equal to each other when we have done 19. Okay, so we've dropped n fruits and we've eaten 19. Sorry, we've dropped 19 fruits and we've eaten 19 fruits. So, but we want to know when it's going to be more than it. So, because 19 is when it's equal to it. So you have to go one more than it. And the answer is 20. Okay, I hope you guys enjoyed that. There's our 5-minute math, episode 3. I will see everybody later. Thanks, everybody.